Welcome to the Planet of Maths channel. In this episode, we will talk about graph shifts. Using the graph of function f, this one here, graph of function g. If function g is described this way, it is f of x minus 2. We have added the number minus 2 to the function's formula. This minus 2 is outside the parentheses. Such a transformation will be a graph shift. Graph shift down by 2 units. In other words, it will be a shift by the vector 0, minus 2. To obtain function g, characteristic points must be selected from function f. Characteristic points are those where the graph turns or ends. You see this point here, this point, because there's a slight bend here. This point, this, and this last one. And we move each of these points 2 down. This point will move here, 2 down. This point will move here, 2 down. This point moves down here, also 2 down. And then this point moves down 2 places to this spot. And this last open point moves down 2 places. So it ends up here. The circle is open, and now these dots need to be connected in order. We connect this one with that one, then we connect this one with that one. We connect here, and the last connection is here. The graph of the function at the top is the graph of the function f, and the graph at the bottom is function g. And here we have the graph of the function shifted down by 2 units. The next example involves shifting the graph of function f according to this formula. Function g of x should equal f of x plus 3. Here this 3 is again outside the parentheses, so the shift will be vertical. And vertically, we move according to this sign, which means we will move up by 3 units. Otherwise, it's a shift by the vector 0, 3, which means 0 horizontally and 3 up vertically. We move this point 3 units up, we get this point. We also move this point 3 units up and get this point. We move this point 3 up, it's here. We move this point 3 units up, it's here. And the last point, such an open one, if we shift it up by 3, it will fit in this place. And now, we can draw the graph of this function by connecting these dots, and it will look like this. And this is the graph of function g, which is formed from function f by shifting 3 units up. In example C, we have function f, and we need to draw function g, which is described as follows. That is, compared to function f, we have to shift this graph vertically. And since it's minus 5, we'll go down as per the sign. Minus means down by 5 units. We move this point 5 units down and end up here. We move this point 5 units down, it is here. This point 5 down is this one. Here another point 5 units down will be here, and this last point 5 units down will be here. The circle is open, and we can connect these points. This forms a graph. This is the graph of function g. So this time we moved function f downwards by 5 units. In example D, we have the graph of function f, and we need to draw the function g, which is described this way. It is f of x plus 2, and this time the 2 is in parentheses. Here, we will shift the graph of the function not vertically, but horizontally. That's what those parentheses suggest. And we will move this graph sideways, to the side, but which way? Plus 2 would suggest we should move this graph 2 to the right, but actually here, these shifts inside the parentheses work the opposite way. If we have plus 2 in parentheses, we will be shifting left, to the left by 2 units. So just like before those characteristic points, meaning this point, we move it 2 units to the left. We are in this place. The next characteristic point is this one. We also move 2 units to the left and land here. We have to shift this point 2 units to the left. It is here. It overlaps a bit there. We must be careful not to confuse which dots belong to which graph. The next point where our graph turns is this one. We move it 2 units to the left. And the last point 2 units to the left. Also an open point to finish off. That's how it would look. Now we need to connect these points in order. We get such a graph, and this is the graph of the function g. This time we shifted the graph 2 units to the left. Another example is this. We have the graph of function f, and we need to draw function g, which is given in this way. The changes are in parentheses. There's minus 3 in parentheses here, so we move horizontally. And since it is minus 3, we move 3 to the right, contrary to what one might think. That is, we move by the vector 3, 0. We need to catch those appropriate points and move this whole function that we have here 3 units to the right. We get new points in these places. So, we need to shift all these characteristic points 3 units to the right, connect these points, and that's how the graph of the function is created, meaning the graph that was created from function f after shifting 3 units to the right. In the example f, we have to shift this function f according to this formula to get the graph of the function g. The shift in parentheses is +4. So we move horizontally, and since it's a plus, we move to the left. These horizontal shifts go the opposite way. 4 units to the left, in other words, by the vector -4, 0. Each of these characteristic points we move 4 units to the left. We move this dot 4 units to the left, this same with this dot, this one, and finally this one. We connect these points together and get a graph of function g. That is this graph shifted by 4 units to the left. In the example g, we already have a specific formula for the function. This function is f of x equals the absolute value of x. And we need to shift this function f so that it becomes function g, given by this formula. Something happens here inside the absolute value, and something happens outside. But let's start with this absolute value function. This absolute value function looks like this. It has a peak, a vertex here, at point 0, 0, and then goes diagonally through the grid. Exactly at a 45-degree angle, it goes one way, but it also goes exactly the same way the other way. It never goes down, because the absolute value is always positive or 0. It all goes upwards, and the graph of this function looks like this. We draw lines passing through these dots, and from this we have the graph of the function f of x equals the absolute value of x. This drawn graph now we have to move. This shift +2 causes a shift 2 up, and a -1 inside the parentheses is a shift opposite to that sign horizontally by 1 to the right. This is the same as if we had the formula g of x equals f of x minus 1 plus 2. We move 1 to the right and 2 up. Actually, here it is enough to just shift this 1 point. This point, this vertex, we shift 1 to the right and 2 up. Here we have this vertex, and from this vertex, you need to go along the grid. 1 way up, and from that vertex, we also go along the grid lines diagonally, also going upwards. And if we connect these dots here, we get the graph of the function g of x equals the absolute value of x minus 1 plus 2. This is the graph of function g, and this function g was created from function f by shifting by the vector 1, 2. 1 to the right and 2 up. In the next example, we again have the function f of x equal to the absolute value of x. Here we already have it drawn. We need to draw a function g, which has the formula absolute value of x minus 2 and minus 2. In other words, it's g of x equals f of x minus 2 and minus 2. The part inside the parentheses tells us whether to go left or right, and the part outside tells us whether to go up or down. Here in parentheses, it goes contrary to what the sign suggests. Since it is minus, we shift 2 units to the right. And here, since there's a minus, as the minus suggests, we move down 2 units, as indicated by the sign. This graph needs to be shifted 2 units to the right and 2 units down, which is a translation by the vector 2, negative 2. So we move this vertex 2 units to the right and then 2 units down. Here we find this peak, and then along the grid, we go in one direction. And here conversely, and we get a graph of function g. This is the function g of x. We have the function f of x equals the absolute value of x. This is the graph of the function. And you need to draw function g, which has the formula absolute value of x plus 3 minus 1. It's the same as if we were to graph the function g of x equals f of x plus 3 and minus 1. This minus 1 in the vertical direction shifts this graph 1 unit downwards. And this 3 shifts horizontally, and since it's plus 3, it's the opposite of what the sign suggests, so 3 units to the left. We move 3 units to the left and 1 unit down. Otherwise, it's a shift by the vector negative 3 and negative 1. So we take the vertex of this function, shift it 3 units to the left, and 1 unit down. Here we have this pointed peak of the function absolute value, and then we need to draw it here along the grid. This creates a graph of the function, and this is function g. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Maths channel.